Good morning guys and welcome back to Dynamics course. In this video we're gonna start by the first chapter in Dynamics, which is chapter 12 in Hibbeler textbook, and this chapter is about kinematics of a particle. So as an outline guys, this chapter will first of all introduce kinematics, and then we'll go over rectilinear kinematics, and then we're gonna go to curvilinear motion in rectangular components, and then in the normal and tangential components. I should also mention the motion of a particle, so we're gonna cover it, and then we're gonna cover the dependent motion as well as the relative motion. After ending this chapter, you have to make sure that you know the concepts of position, displacement, velocity, and acceleration. You are able to do the study of a particle motion along a straight line, which is called rectilinear motion, along a curved path, which is called curvilinear motion, the projectile motion, and then you can do the analysis or the study of dependent motion as well as the relative motion. Now guys, as an introduction, and as we said previously in lecture 0, I know that mechanics is divided into two parts, statics and dynamics. I know that statics, guys, is either when the body or when the particle is at rest or at a constant velocity. So it deals with the equilibrium of this body, and that's why I have to apply the first law of Newton, sum of forces is equal to 0. And also, I know that dynamics is when I have an accelerated motion. Accelerated motion means I have an acceleration, and I should apply the second law of Newton, where I have the sum of forces is equal to the mass times A. And then, guys, we said in the previous video that dynamics is also divided into two parts. The first part is called kinematics, and the second part is called kinetics. And we're gonna go over kinematics before kinetics, although guys, kinetics is the cause behind kinematics. So kinetics deals with the analysis of the forces that are causing this kinematics, and kinematics, in fact, they deal with the geometrical aspects of the motion, like the position, the displacement, the velocity, and the acceleration. So let's start the kinematics of a rectilinear motion. What does this mean? What is a rectilinear motion? Rectilinear motion, as its name in French, rectilinear, means I have a straight line path. So this particle is going over a straight line path. Alright? So the path of this particle is straight, which means it could be horizontal, it could be vertical, and it could also be oblique. So if I have, guys, this motion, for example, this is not a rectilinear motion. However, if I have a straight line, then this is a rectilinear motion. So guys, how to find the position, velocity, and acceleration in rectilinear motion? First of all, let's start by position. And by starting, guys, by this term, position, I want you to differentiate four main parameters. R is in vector form always. And guys, I want you to know that if there is a symbol in bold, this means that it is in vector form, all right? So if there is a symbol in the slides on bold, this means that this is a vector parameter. R, S, delta S, and ST. So let's start by differentiating these parameters from the very beginning of this chapter. Because guys, I don't want you to be confused by the difference between them, alright? So guys, R As you see, this is a vector, all right? Which means it has a magnitude and it has a direction. This is a vector. And this vector is called position vector. Now, how to indicate this position vector? I should, of course, have an axis, all right? So let's say this is this is a straight axis. I'm gonna call it S, like X or Y, all right? But I will call it S, guys, because it could be oblique, all right? So S could be oblique, unlike X, which is horizontal, and Y, which is vertical. But this doesn't mean that S could not be horizontal or vertical. It could be. All right? Now, I'm going to call this axis S. And it is a single coordinate axis. So why it is single? Why I don't need another axis? Because in fact, the path is rectilinear. So since the path is rectilinear, I only need one axis in the direction of this path. Alright? So if the path is oblique in this direction, I have to take S as the same direction of this path. Alright? So this S should be parallel to this path. So that's why I only need one single coordinate. And I also need O, which is a fixed point, and this will be the origin of this path. Now guys, how to find the position vector R? Let's specify P as the position point of this particle at an instant t. So at t, guys, I know that P is at this location. So what will be R? R is the position vector of P, which means R in vector form is equal to O P. I always start from O to P, alright? So it is O P. This is the vector position R. Now let's say at T prime, this particle arrives to a point here called P prime. What will be R prime, which is the new vector position? It should be O P prime. So R prime will be O P prime. Now what if at an instant t second, so t double prime, P, the particle, is now at this point P double prime? What do you think, guys, is R double prime? R double prime is now O. I should always start with O, the origin, P second, or P double prime. So as simple as that, guys. This is the vector position R. R is the position from the origin to the point of, or to the location of this particle. Now, what about the sign of this vector? Is it positive or negative? In fact, guys, if this OP has the same sense or the same direction, which is here to the right of O. If it is to the right of O, which is the same direction as S, then it should have a positive value, or it should be a positive vector. If not, like OP second, it should be negative. Alright, so guys, this means that R and R prime are positive vectors because they are vector positions at the right side of O with S. And OP second is negative because it is at the other side of S. It is in the negative axis. Now guys, what is S? S, guys, is the algebraic value of r. It is a scalar, so it could be positive and negative. S is never the magnitude of r, because if S is the magnitude of the vector position, then S, guys, is always positive, and this is not the case of S. S could be positive and could be negative. S is the algebraic scalar. It is an algebraic value. It is a scalar. It could be positive or negative. All right? So it's not the magnitude of R. No. S is the algebraic value of R. It is not a vector, but it is positive if P is at the right side of O with S, and negative if P is at the left side of O, which is the negative X. And this means, guys, that S is OP. And this OP could be positive or negative. So S, guys, could be positive or negative. It is not the distance and it is not the magnitude of R. Now, what is delta S? Delta S is basically the difference between S prime and S. So it is S prime minus S. And this is called displacement. So this is the displacement, guys. Delta S is S prime minus S. Now what is S prime? It is OP prime in algebraic value minus OP. So guys, delta S is the algebraic value of delta R, where delta R is the displacement vector. Alright, so delta R, of course, is R prime minus R in vector form, which means it is OP prime minus OP. Now, delta S is positive if S prime is greater than S, which means, guys, S prime is, or which means the particle is moving to the right side. Now, if the particle is moving to the left side, so let's say this is the initial position, this is P. If this is P second, and I know, guys, that delta S will be S second, so this is S second, it is always from O minus S. And this means, guys, that delta S here in this case is negative, all right? Because it is at the left side of the initial position, all right? So this is what is called displacement. The final parameter that I listed here is ST. And guys, ST is a very important parameter because I'm gonna use it later on in the average speed. ST, by definition, is a positive value. It is a distance that represents the total length of the path over which the particle travels. I'm now confused. What does this mean? And what's the difference between ST and delta S? Let's see it in the next video. Thank you.